some basic properties of magnets and certain terminologies used in describing a magnet. Magnetic dipole moment. This is a bar magnet. Bar magnet, there will be a north pole and a south pole. North pole and south pole will extend a little in then. This is geometrical length. Distance between the poles is called magnetic length. From the geometric center to the one pole is L. So this will be 2L. Then magnetic dipole moment is PM. Magnetic dipole moment, PM vector, is equal to QM. So this QM is the pole strength, or we can say magnetic charge. In electricity, we are using the word charge. Here, magnetic charge, corresponding quantity is magnetic charge. Then D vector. D vector is a vector from south pole to north pole. Magnitude of the dipole moment is PM is equal to QM into D. Then magnitude of D vector is this 2L. So for this D we can write 2L. So this is the magnitude of magnetic dipole moment. Then SI unit of magnetic dipole moment is ampere meter square. Now let us try to understand what is magnetic field. Here there is a bar magnet. You keep another magnet, then it will experience a force. So suppose the north pole is near this north pole. North there will be repulsion. If south pole is kept near this north, it will be attracted. So its influence is experienced. Then magnetic field is the region or space around a magnet in which its influence is felt. Magnetic field is a vector quantity, strength of the magnetic field. Suppose you keep a north pole, north, there will be repulsion. It's a magnetic dipole, but you can imagine a north pole. There cannot be north pole alone, but we can imagine a north pole. In electricity, there are positive charge, negative charge. But in magnetism, we cannot have north pole alone, but we can imagine a north pole. Suppose you keep a north pole here, north, there will be repulsion. Suppose here north pole is kept, there is an attraction. That means here field is to that side. Here north pole is kept, so it is attracted. So there are magnetic lines of force. It will start from north pole and end at south pole. That we will see later. Magnetic field can be represented by magnetic lines of force that we will see in the next video. Now, strength of the magnetic field is represented as B vector. Strength of the magnetic field is defined as the force experienced by unit north pole or a magnet of unit pole strength. So you divide by the pole strength. Suppose you keep a bar magnet of pole strength QM. It is experiencing a force F. So if you divide, you will get the force experienced by unit pole. So magnetic field strength is defined as the force experienced by a bar magnet of unit pole strength. Force is measured in Newton. Pole strength is measured in ampere meter. So it can be written like this: Newton, ampere raised to -1, meter raised to -1. Types of magnet. There are two types: natural magnets and artificial magnets. Naturally occurring magnets are of irregular shape and it will be weak. For example, hematite, an ore of iron, will attract pieces of iron. So it's a natural magnet. So it's weak and irregular. Then artificial magnets. We can make magnets of desired shape and strength. If the magnet is in the form of a cylindrical shape or rectangular shape, it is called bar magnet. Thank you for watching.